All right, so first thing I always do when I've been asked to describe the end behavior is I take just a moment and I write it out in words to myself, just short and sweet, and then I write my math sentences from that. So on this graph, what do you see happening on the right side? What is happening on the right end of this graph? Again, I just want words. Is it going up or down? Right side of the graph. Down. So the right side is pointing down. Again, I just take a moment and write it out in words so that when I go to write that math sentence with all those symbols, I know what I'm trying to make it say. What's the left side doing? Going up. So I just write myself a little note. Left, up. Now I'm going to write those math sentences. Which end do you want to start with? It doesn't matter, but I want to take just a real quick, what do you guys want to do? Right side, sounds good. That's my favorite one to do first also. How do I say the right side? I know I have to start with as, x, arrow, positive infinity. This is how we say the right side.
Shouldn't we usually start with left?
You can start with whichever side you want. When they have it filled in, we got to be careful and read it. But when we're writing the whole sentence, it does not matter which one you write first, as long as you get both ends. All right, as x, arrow, infinity, we're talking about the right side, comma, what do I put next? F of x, because now I'm talking about what the graph is doing or what the outputs are doing. What did we say the graph is doing on that side? Going down, and so we write a negative infinity. Absolutely correct, Jaden. This is how we say down. Am I done with the end behavior? Why not? Got to write the other side. We wrote about the right side of the graph. Now I need to write about the left side of the graph. So how does the first part of my sentence look different when I write about the left side? Yep, as x approaches. Why does this have a negative with it? Why does that mean left?
Because left is negative.
Yep. When I look at a graph right here, the left side of the x-axis, that's where the negative numbers live. So if I'm talking about the left side, I'm talking about the negative things. So as x approaches negative infinity, my graph f of x, what did we say that side was doing? Going up. How do I say that in math? Infinity. So this right here means up. You have to have both of those sentences. I don't care which one you put first and which one you put second if you are writing them all out for me. If you're filling in the blanks, make sure you are careful about which one they have first. All right, that's the first piece that we were asked to do. We finished that up. Now we need possible degree. What did I tell you to look at on the graph for possible degree? Look at the number of x-intercepts. How many x-intercepts does this graph have? 3. One here, and one right here. It has 3 x-intercepts, which is the same thing as real roots or real zeros. So what is our possible degree here? Remember, the degree is going to be the biggest exponent on an x. It has to be a number. 3. Possible degree is 3, coming from 3 x-intercepts. So far, so good? Yep. All right. Talk to me now about the leading coefficient. What do you know about the leading coefficient? It's negative. How do you know? I heard somebody say something about the right side. What do you see on the right side? It's going down. That's how I know the leading coefficient is negative. Whatever the right side is doing, whatever I said up here about the right side, that tells me the sign of my leading coefficient. What's another way that I can write this? It'd say A, because we use A for a leading coefficient. How do I say negative with symbols? I want to say that it's a negative number. What's the dividing line between the positive and negative numbers on the number line? No, just the number line. What's the dividing piece between the 0? So if it's negative, is it going to be greater than or less than 0? Less than. This is another way to write negative. I am perfectly fine when you are just writing things out in words for me, for you to write it like this. I want to make sure that we know how to recognize this as meaning the same thing. Because on a multiple choice question, you might not have this option. You might only have this option. And I want you guys to recognize that that's saying leading coefficient is a negative number. It's smaller than 0. So far, so good? All right. We're going to do one problem out of your book today. It's going to give us a chance to practice substituting in again. Then we're going to compare two functions. Then we're going to do two homework problems together. So if you've been keeping up on the homework, you should be almost done with it by now. We're going to do the two hardest problems together after we do the example out of your book. And then whatever remaining time we have, you guys can finish up working on the homework. I'm also going to pass back your tests today so you guys can see how you did on that.
I want to see more. You can keep on.
All right. Page 218 for me, please. Page 218. We're going to compare and contrast two different graphs here. First thing I want to do is label these guys. Because while your book has them labeled, it's really tiny print and it's very hard to see. Do you guys see the graph that looks kind of like this weird W? Do you see how it has a tiny little speech bubble?
Yeah.
That's telling me the name of this function. This is the function g of x. That's what this is a graph of. I want you to label that in your book because we're going to be comparing and contrasting that one with the other function f of x. Okay, no worries. All right, so we labeled our function g of x. What do we know about the function f of x? Because that's what we're going to be comparing and contrasting it with. What do they tell me about f of x? Look all the way up at the top, right underneath where it says example 6. What do I know about f of x? What does it tell me? Right after it says examine, what comes after that? F of x equals x to the third plus 2x squared minus 3x. This is the function rule for f of x. They gave me an equation for this, but for g of x, they only gave me a graph. This guy right here. They went ahead and graphed f of x for us. That's this guy down here. So here's the graph of f of x. Do they have that table all the way filled in? No. We're going to get some more calculator practice today with substituting in. Grab your yellow calculators. What are the pieces that they didn't fill in for us? What did they not fill in? They didn't fill in for x equals -2. They didn't fill in for x equals -1. Oh, sorry. 0. I pointed at the wrong thing. They didn't fill in for f of x equals 0, or for x equals 0. And they didn't fill in for what else? 2. So in your yellow calculators, we're going to take that function rule for f of x, and we're going to substitute in these numbers. So we're going to do f of -2 first. What does that mean? What do I want you to do with this function rule here? Substitute in -2 every single time you see an x. So what's the first button you need to hit on your calculator if we're making substitutions? Parentheses. So open up parentheses, and what are we putting in for x?
2.
-2. And then you're going to close your parentheses because that's taking the place of the x right here. And then what are you going to do to this number? Put a degree of 3. Put an exponent of 3. Do you guys remember how to change the exponent to a 3? It's that triangle without the bottom. It's very near the 7 key.
Yeah.
What do I do next after that? Plus 2 and then parentheses. Absolutely correct. And what do we put in these parentheses? -2. Exactly the same thing that we did before. Do I need an exponent on this one? Do I need an exponent here?
Yes.
Yes. What is that exponent?
2.
Right here. It's x squared. We put in -2 for x, so we are now going to square that. Do I need to put in anything else into my calculator, or am I done? -3. Parentheses -2. And then you will hit the enter key. Let me make room for this on my screen. What do you get when you hit enter? What'd you get? 6. So we put this number here, and here, and here. I want you guys to repeat this process for 0 and for 2. We got 6. Yep. Did you use parentheses every time you put an x in? Because if you didn't use parentheses, you're going to get a wrong answer. So it should be parentheses -2, close the parentheses, cubed.
Oh, I did.
Yep, no, it's -2. Because we're right here on the x. I want you guys to do the same thing for 0 and for 2. I'm going to give you about 2 minutes, one for each of those. And then I'm going to take your answers on those. You need your head up, sir. You need to be doing this with us. Come on. Right here, dear. You need to substitute in with the 0 and then substitute in with the 2. For the next one? Mm-hmm. So write that in your book and then do the last one.
The last one?
Yep. 2. Mm-hmm.
You make everything sound so simple.
That is certainly what I try to do. If I make it sound easy, we're more likely to try it.
Can you figure out whether you're going to do the math or anything AP statistics?
This year I'm doing AP Statistics. I don't know what they're going to have me doing next year.
In a row.
Okay.
I got the rest.
What'd you get when you guys substituted 0 in? 0. What about when you substituted 2 in? 10. Is this doing what we saw in the last unit where like it reflects? When you look at the graph, does it make sense why it's not reflecting? Remember, my parabolas had line symmetry. They could be folded in half. Does this have line symmetry like that? No. All right, so we've filled in our table. Once I have a filled in table of values, I can plot those points and sketch the graph. They did it for us already to save us some time. Thanks, book. All right, I want to analyze their extrema. Which function has the greater relative maximum? What is a relative maximum? A high point. Does it have to be the highest point? Just has to be a high point. Relative means it does not have to be the highest. If you left that word relative off, then it does. Relative just means a high point. Are there any high points on here?
Yep.
Yep, where? Yep, right here. This is the relative maximum on this graph. I'm going to do that in purple, actually. Bye, dear. Here's a relative max. What about on the other one? Does it have a high point at all?
Yep.
Where is its high point?
6, -2.
Yes. Actually, we'd say the x part first. Yep, so here's our relative max here. Is that relative max on our graph g of x, is that the highest it ever goes? Why not? Arrows go up higher. On the graph of f of x, is that the highest the graph ever goes? Why not?
Because arrow on the right goes all the way up.
On the right side, it goes up higher than that, right? So which one has a higher relative maximum? Second one. Why?
Because the height is 6.
Yes, this one is at a height of about 6. This one is somewhere in between 2 and 3, so like 2.5 or something. 6 is a bigger number than 2.5. Has a relative maximum at approximately 6. Here it's between 2 and 3. So f of x has the greater relative maximum. Remember, they've got these little speech bubbles here to tell me the names of each of these. This one here is g of x. The one on the bottom is f of x. All right, so let's talk about our x-intercepts, our y-intercepts, and our end behavior. What are the zeros for f of x? First of all, what am I even looking at if I'm looking at the zeros? Give me a synonym for zeros. Solutions, x-intercepts, and roots. Remember our synonyms there. Zeros are the same things as the solutions. The roots, the x-intercepts. I want to look at f of x first. That's this graph right here. Does it have any x-intercepts? Where are they? On the x-axis. So tell me the numbers. Where are we crossing the x-axis at? At -3, 0, and 1. Right here. Right here. You need to be writing this down with us, sir. and right here. These are my zeros. It's just the same things as my x-intercepts. What do they ask me about right here? What do they want me to tell them about right here, guys? X-intercepts. Didn't we list those already? So we know what goes on those 3 lines. Where are my x-intercepts? -3, 0, and 1. All right, let's go to our graph g of x. Does g of x have any x-intercepts at all? Does g of x have any x-intercepts at all?
Yes, yeah.
How many?
No, 4.
4 x-intercepts. Where are they? 1, 2, okay.
Yeah, 0.5 negative.
0.5 and -1, I like that.
Negative
0.5, -0.5, absolutely correct. This one has 4 zeros. Those are the same things as my x-intercepts. They are at -1, -0.5, 1, and 2. So what should I put down here for the x-intercepts for g of x? Guys, phones down for me.
I'm sorry. What you said?
What should I put on these 4 lines here for the x-intercepts of g of x?
No, 4 numbers.
The same 4 numbers. Zeros are the same things as my x-intercepts. So -1, -0.5, 1, and 2. So I'm curious. You told me f of x has 3 zeros, 3 x-intercepts. So this is possibly a degree what? Yep, for f of x, this is possibly a degree 3. What about for g of x? Possibly a degree 4 here. All right, end behavior. Talk to me about the end behavior for f of x. This guy down here. What's happening with my ends? Right side is going up, left side is going down. They wrote part of the sentence out for us. Which end are they talking about first? They're talking about the left first. This right here means left. What did you tell me on this graph the left side was doing? Going down. Go away. Negative infinity is how I say down. Which side is this one right here?
Right side.
Right side. What did you tell me the right side was doing? How do I say that? Positive infinity.
I feel like we've done this.
We did it back in August, and then we're revisiting it. We struggled with it a lot in August, but that's the first time you guys ever saw it. This is the second time around, and I feel like we're getting a much better grasp of it second time around. What about my graph g of x? What are my ends doing here? They're both going up. So what do I want on both of these lines? Positive infinity on both lines. Beautiful. One last thing I want to look at before we do your homework problems together. Go back and look at the table. You remember you told me there's 3 x-intercepts here, 3 zeros? Go back and look at that table that we filled in. How can I use the table to figure out where my x-intercepts are? Where did you say those x-intercepts were?
When the right side of the table is on 0.
Yes. So we're going to look here. For zeros to find the x-intercepts. So I see one right here. -3, 0. You told me that was one of them. I see one right here at 0, 0. That's another one that you guys told me about. And right here at 1, 0. This right here is why we call them zeros. Because it's going to have a 0 in this column right here. All right. We are totally done with the examples in your book. The homework problems that we're going to do are 17 and 18 on McGraw-Hill. But if you want to follow along in your book, we're going to do number 35 and number 36 from the book. So question 17 on McGraw-Hill is number 35 in your book. Nope, number 35, page 221 or 222. I think it's 222. Is it 222? Okay, that's what I thought. Page 222, number 35. This is question 17 on McGraw-Hill. A box has a square base. What does a box look like? Yeah. What do you do with a box? Put stuff in it. It says that it has a square base. So the bottom of my box is something like this. My art skills are only so good, so please don't hate me. All right. Do we know how big those sides are of that square?
Yes.
How big are they?
10 centimeters.
10 centimeters, and because it's a square, that means both sides are going to be 10 centimeters, right? Is that a picture of a box? No.
No, that's it.
What do I still need to make this a box? Height. What is the height of this box?
4 centimeters.
4 centimeters. So something like this.
That's a rectangle.
Is it a rectangle?
Yeah.
I mean, put stuff in, it's still gonna be boxed.
Oh.
The sides are rectangles,
Yeah.
but it's a box. I can put stuff inside
oh, yeah,
of it.
Yeah, it is a box.
Yeah.
Yeah. Like it's a rectangular box right there.
Yeah. Yep. Got a whole bunch of examples. This is kind of like a cereal box laid on its side, right?
Yeah.
Or maybe a shoe box. What are they going to do to this box?
I know. It's 3D.
What are they going to do to this box? What does it say?
The height is increased by twice the number x, and the length of both sides of the base are decreased by x.
Yes, the height is increased by twice a number x. If it's increasing, would I be adding or subtracting? Adding. Increased means to add. What is twice a number x?
Times 2x.
2x. We're going to add 2x. Where am I adding 2x in the picture?
To the height.
To the height. Which piece is the height?
4 centimeters.
4 centimeters. So it's 4 centimeters plus 2x. Because we're going to add 2x onto it. So far, so good? Are we doing anything else to this box?
Decreasing it by x.
Decreasing the lengths by x. If I'm decreasing, am I adding again?
No, you're subtracting.
I'm subtracting. Would it be x minus 10 or 10 minus x? Which thing am I taking away from?
10 minus x.
10 minus x. I started with 10, and then I'm going to take this part away.
Quick question.
Yes.
Is the sum So sum is times, increase is add.
Sum is add. Increase is also add. Product is times. Mhm. All right, so now I have the new length. I have the new width. And I have the new height. It said write and graph a function that represents the volume. How do you find volume? How do we find volume for a three-dimensional object? Length times width times height. So my volume, what is the length of this box? The new length. I drew it on my picture. What did I say the new length was? 10 minus x. It started off as 10. For the new length, they're going to minus x from that. So 10 minus x. There's my new length. Times the width. What's the width? 10 minus x again. Am I done? What else do I need? The height. What is the new height? 4 plus 2x. I'm going to scoot this over just a little bit so that I have room to write new height. That is the volume. That's what I'm going to put right here. I have length times width times height. This right here goes in this box. Ten minus x times 10 minus x times 4 plus 2x. Let's graph that. I want to know what this looks like. I went ahead and graphed this already. I need to switch this around though. I wrote it backwards. All right, you guys ready to see what this looks like? There it is. Does it have a relative max anywhere?
Yeah.
Where is the relative max?
500.
What's the x part for the relative max?
2.
2. And it looks like it's in between what two numbers? 400 and 600, so probably about what?
500.
It's 512.
I forgot this.
How could I... Let me get rid of this for a second. How could I find out that number right there? If all I knew was the height was at 2, what could I do with all of this to get that number? Substitute. What would we substitute in for x? 2. Grab your calculators for me. We're going to do that. I have 10 minus 2. And then inside parentheses, another 10 minus 2. 4 plus 2 times 2. What'd you get? $512. What is 10 minus 2? 8. So So 8 times 10 minus 2 again would be another 8. What is 2 times 2?
4.
4. So I have 4 plus 4 here. What is 4 plus 4?
8.
8. Grab your calculators real quick again for me. I want you to do just 8 times 8 times 8. 512. Let's go back here. The graph appears to have a relative maximum at x equals 2. So when we substituted in 2, we got what back? What was the y value that we got as output? Just a moment ago, I just had you guys do it on your calculator. 512. So the dimensions of the box with the greatest volume will be, when we put a 2 in here, 10 minus 2 gave me 8. 8 centimeters by what? 8 centimeters by 8 centimeters. Because again, we did 10 minus 2. That's how we got one of the 8s. Times 10 minus 2. That's how we got the other 8. Times 4 plus 2 times 2. That's how we got our last 8. What units would go on each of these? Centimeters. 8 centimeters by 8 centimeters by 8 centimeters. Length, width, height. If it's 8 by 8 by 8, what would we call that shape when all the sides are the same?
Square. I mean, box. Square.
What kind of a box? Cube. A three-dimensional shape where the length, the width, and the height are the same. That is a cube. All right, let's go do number 18. We're going to find the error here. This is number 35 in your book. Or sorry, no, number 36, my bad. We just did 35. Number 36 in your book, page 222. Got this weird graph. Shaniqua and Virginia are determining the number of real zeros on the graph. Is either of them correct? Explain your reasoning. Shaniqua says there are 7 real zeros because the graph intersects the x-axis 7 times. Virginia says there are 8 real zeros because the graph intersects the x-axis 7 times and there is a double zero. A double zero is where it looks like the graph bounces off the x-axis. Is there anywhere that it looks like the graph bounces off the x-axis?
Yeah.
Where? Left side or right side?
Left.
Left side, right here. That's what it's talking about right here. How many times does this graph cross the x-axis or touch it, intersect? There's once right there. How many other places? 1, 2, 3, 4, 5, 6, 7. So yeah, there it does intersect 7 times. But what does that mean about real zeros? Who's right here? Shaniqua is right.
The name is crazy.
When you have a double root like this right here, I still only count that number once. It's like if I gave you guys each numbers in the room and I was calling you for groups out in the hall and I accidentally called somebody's number twice. Do 2 different people show up? No, same person shows up. So Shaniqua is correct. The number of real zeros is equal to the number of x-intercepts. Shaniqua is correct. All right. So when it comes to homework stuff, Tuesday's lesson, you should have been able to get the first 5 knocked out. Yesterday's lesson, there were 9 problems, but that's because that second set, 15 through 20, was just real fast, just a single number. How many x-intercepts do you see? We just did 35 and 36 together, so if you've been following along, you should only have 2 problems to finish up. I'm going to pass back your tests from before break. You do need to return these to me. If I don't get them back from you, it goes into the grade book as a 0 until I get it back from you. Once you're done looking at it, if you don't have any questions, make sure you turn it back in to me.